Okay, number 1. You're given that angle 3 and 2 are complementary. So 3 and 2 are complementary. And that 1 and 2, the measure of angle 1 and 2, are 90 degrees. So we can start by saying angle 3 and angle 2 are complementary, and measure of angle 1 plus measure of angle 2 equals 90. And what allows us to do that is that it was given to us. The next thing says measure of angle 3 plus measure of angle 2 equals 90 degrees. Well, up here we said that 3 and 2 are complementary. Down here we define complementary, and it says that two angles that are complementary, 1 and 2 angles that are complementary, have a sum of 90 degrees. A sum of 90 degrees. So what allows us to turn complementary into this is the definition of complementary angles. They have a sum of 90 degrees. Okay, the next line we say that measure of angle 1 plus measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Well, it kind of looks like angle addition, but angle addition would be that angle 1 and angle 2 equal this whole big angle, and that's not what we have. We have angle 1 and angle 2 equals 3 and 2. Well, here we had angle 1 and 2, and here we had angle 3 and 2, and if you notice, we've replaced them, the two 90-degree angles, because these sets of angles are 90 degrees and these sets of angles are 90 degrees, we can say that they are congruent. And yes, it does look like substitution, and yes, it is technically substitution, but to be more geometrically formal, we call this the congruent complement angles theorem. That angles that are both complements are also congruent or equal. Alright, from this line to this line, you notice that angle 1 is still there, measure of angle 1 is still there, measure of angle 3 is still there, but we lost the measure of angle 2 from both sides. And the only way to get rid of or to lose the measure of angle 2 on both sides is to subtract the measure of angle 2 from both sides. So that's our subtraction property of equality. Then this step, we lose the m and it's gone, it's not there. We lose the m, it's gone, it's not there. The equal sign turns into a congruent sign. Anytime you change an equal sign to a congruent sign, that's called the definition of congruent and then whatever we're referring to. So in this case, we're referring to definition of congruent angles. It says that angles that are equal are also congruent. Angles that are congruent are also equal. Okay, number 2, we're given that angle QPS, Q to P to S here, is congruent to TPR, T to P to R here. And we want to prove that QPR, this little one, is congruent to TPS, this little one. So first statement, QPS is congruent to TPR, that's in our given, so that's our reason. Here we have the measure of QPS, angle QPS is equal to the measure of TPR. And all that's happened is our congruent sign turned into an equal sign. The measure, the m showed up, and the m showed up here. So all we've done is we've defined congruency, and that says that congruent angles have equal measures. But that's the definition of congruent angles. The next one, the measure of QPS is equal to the measure of QPR plus RPS. So here's QPS, this one right here, and it says that that's equal to the measure of QPR plus RPS, making up that big angle. That's angle addition. The next one says TPR, T to P to R, is made up of or equals TPS, this angle, plus RPS, this angle. So it's saying little angle plus the little angle equal the whole angle. That's the angle addition postulate. Just like the segment addition postulate, two pieces make up the whole. Okay. Next one says the measure of QPR plus RPS equals the measure of TPS plus RPS. Well, we have the QPR and the RPS from here. QPR and the RPS from here. We have the TPS and the RPS from here. TPS and the RPS from here. And the only way that we can have QPR equal to plus RPS equal to TPS plus RPS is by substitution. And let me explain how we do that. The QPR plus the RPS we said was equal to QPS. Up here we said QPS equal TPR. So technically I can say, since QPS and TPR are equal, I can call this one TPR. And TPR equals QPR plus RPS, and TPR equals TPS plus RPS. Since these two equal each other, I can replace this TPR right here with what we said TPR equals, which is the measure of angle QPR plus RPS. So I've replaced this value here with what it equals. And that's called the substitution property. All right, down here, QPR has stayed, RPS is gone. TPS has stayed, RPS is gone. The only way to get rid of the same thing from both sides of an equation is to subtract RPS from both sides of the equation. So that's our subtraction property. And then the last one says that measure of angle QPR equals the measure of angle TPS, and then we say QPR is congruent to TPS. Well, the equal sign has turned into a congruent symbol, the M is gone, and that's the definition of congruent angles. It says that angles whose measures are equal are congruent.